So in this video we'll see the reactions of fatty acids, that are reactions of fatty acids. So first of all we'll see what are fatty acids. Fatty acids are basically the long chain alkyl groups which contains mono carboxyl group attached to this, that is a long chain of, like that we can see that long chain of alkyl group having only monocarboxyl, that is COOH, monocarboxylic group attached to it, hence called as fatty acids. Here we can see that fatty acid. So examples are stearic acid, that is 18 carbon chain palmitic acid, lauric acid, myristic acid, etc, etc, arachidonic acid, that is unsaturated acid, timnodoic acid, tuberculous acid, etc, based on the classification system. So first reaction is esterification reaction. Here what will happen is that in esterification reaction the ester will be formed, that is the name itself suggests that esters, that is ester will be formed. And what we'll see, what will happen is that L1 alcohol, so that is the alcohol, any type of alcohol, that is ethanol or propanol, etc, type of alcohol reacts with what we can say the fatty acids in the presence of the mineral acid, that is H2SO4, and HCl, that is hydrochloric acid. It will give ester, that is any type of palmitate 8, that is the class, that is the nomenclature of the ester, and along with the water. So we have ethyl palmitate, we have what we can say palmitic acid, so CH3, CH214, and COH, that is palmitic acid, along with we can say that ethanol, C2H5OH. So what will happen here, this OH group and this OH group will lead to the formation of the water, that is water will be formed along with the main product as a byproduct, and in this HCl or H2SO4 will be added as a heated, and we'll get, that is CH3, CH214, and COOC2H5. So this is ethyl palmitate, and the naming for this is ethyl palmitic. It is palmitic acid along with the OH, but it is ester, so we'll get ethyl palmitate, and the nomenclature we can say ethyl palmitate, and with the nomenclature we'll get it is at means for the nomenclature of the esters will be like this, that where the ester, that is the carbon chain having less than the main parent chain will be written will be prefixed, that is ethyl is prefixed, and afterwards will give the palmitate, that is the parent name chain palmitate, that is palmitate along with the ester. So next is ester. After that esterification we have halogenation, and now what will happen in halogenation, the name itself suggests that is halogen will attach to the double bond, that is unsaturated fatty acids. Here in what we'll see, the linoleic acid, that is we have CH3 and 18 carbon chain, CH3 CH2, and we have 4 CH2 and CH double bond, CH 2 CH, and double bond again CH2 7 and COS. So we have 1 8 9 10 11 12 13 14 15 16 17 and 18. Okay, so we have linoleic acid. So we have linoleic acid on reaction with iodine monobromide or iodine monochloride, plus addition of iodine monochloride will get the addition of this on this position, or not position, this only single position will get addition on this 1 2 3 4, that is. So how will it look like that, CH3 and CH2 we have 4, and CH here will get iodine attached, C single bond CH iodine will be attached 1 2 3 and 4, and CH2 and another iodine will be attached here, and now and the other iodine will be attached here, and CH2 4 7 and COH. So we'll get tetraiodo stearic acid. So what will be conclude from what will be concluding from this, that the unsaturated fatty acid, the linoleic acid, on the halogenation with iodine monobromide or iodine monochloride, it will form tetraiodostearic acid or saturated fatty acids. Tetraiodostearic acid, which is saturated fatty acids, that is which are attached here, tetraiodostearic acid. So the next reaction is oxidation. Oxidation reaction is a very famous reaction. Here what will happen, for example, let us take oleic acid. We can oleic acid CH3 to CH3 and CH2 7 double bond CH CH2 7H9. okay, so CH2 7 and COH. So what will happen here on oxidation with KMnO4? We get two types of this KMnO4, and we'll get ozone on the reaction with ozone. So we'll get KMnO4 on this, we'll get CH3 and CH27. So we'll get what, let's count for this. It was stearic acid or not, 7, 8, 9, and 9% 16, 17. So we'll get here CH, one CH attached here. So what we'll get here, that CH3 CH27 on the oxidation with, it will form CH hydroxy group attached to it, CH27 COH. So here all we can see that OH group is attached, the hydroxyl group will be attached. And on further oxidation, we have seen that in the oxidation of the alcohols, in the oxidation of alcohols, what product, the suitable product we get is that when an alcohol is first oxidized, it will get aldehyde, and when it is first oxidized, it will get what we can say, we'll get carboxylic acid. So when we'll oxidize it another, we get, this will be oxidized at COH. So CH3 CH27 COOH, that is COOH. We'll get smaller acids plus another COOH and CH27 and COOH. We can also write SCOC, that is smaller acids will get that means what it concludes that a long chain fatty acid, that is oleic acid, having unsaturated fatty acid, which is unsaturated fatty acid, can be broken down into smaller acids based on the oxidation, that is KMnO4 used. And now when the ozone is used, we get ozonolysis. Reaction is done here, ozonolysis. Lysis means breaking down in the presence of ozone. So what we'll get here is that CH3 CH27 and CH27 CH is attached here on O, and OCH. We get CH27 COOH. So what we'll get here, H is attached here. So O, a type of structure will be like the type of structure like this will be. So what will happen here is that I have this type of molecule, and then the removal of the water molecule minus H2 will be taken, wherein the water will be removed, and we'll get the aldehydes. So how we'll get aldehydes? That this H is removed along with this water molecule, so we'll get double bond O along with this. So how we'll get this CH3 CH27 C double bond OH, that is aldehyde, called as aldehyde. And this product will get as CHO HCO CH27 COOH, that is semi-aldehyde. It is called as semi-aldehyde because it contains HCO, that is HOC, that is one aldehyde group and another the carboxyl group attached to it. So we get semi-aldehyde, and it is as simple as, very simple. So oxidation we have seen in the presence of KMnO4 oxidizing agent, and the strong oxidizing agent, and another is the ozonolysis we get in oxidation. KMnO4 will get as smaller acids, and along with the ozonolysis we'll get the semi-aldehyde and aldehydes. Very simple. And for next, what we'll see that, and the next reaction is hydrogenation. Hydrolysis will be seen in the reaction of fats and oils. So hydrogenation, what the name itself suggests, the hydrogenation means the fatty acids which are, what we can say, that unsaturated fatty acids on addition with, or addition of the hydrogen at greater than 50 degrees Celsius will be saturated fatty acids, or the esters which contains, so will be converted into hydroxyl alcohol. So what we'll see that here we have oleic acid, that is CH3 CH27 CH double bond CH, and we have again CH27 COS. So what will happen here, that is hydrogen plus nickel, and greater than 150 degrees Celsius heat will be provided. So what we'll get here is that CH3 CH27 CH, and another we have CH2 and CH2 CH27 COS. So here we had oleic acid, and after the hydrogenation we got stearic acid. So basically, if this is oil, then it is converted into fat. We will see it later in the next video, how that oil is converted into fat after the saturation value. And also we have various saponification value, iodine value, which determines their acidity, and also the saturation, that is if whether it is oil or not, based on that. So in the next video we'll see this. So this hydrogenation, the unsaturated fatty acid, this is unsaturated fatty acid converts to saturated fatty acid. So the next point is halogenation, and the next is last one is saponification. Saponification, the name itself suggests sapon means soap. Soap formation. Here, what we'll say soap formation means the metallic salts, that is KOH, that is potassium hydroxide, will react with the fatty acids to form the potassium. That is, for example, we can take a fatty acid as palmitic acid. When palmitic acid reacts with potassium hydroxide, we'll get potassium palmitate and the water molecule. And when this potassium palmitate reacts with what we can say, again reacts with mineral acid HCl2SO4, will get the potassium, will get the same mineral acid, that is the same fatty acid, that is palmitic acid. Now let's see what soap formation. Metallic salts, for example, we have CH3, we have CH2 7 COOH, that we have CH2 7. Okay, so okay, CH3, CH2 14, and we have COOH 14, 15, 16. So there is palmitic acid, and plus will react it with KOH. So in the presence of what we can say, or hydrolysis, we can say that then the hydrolysis, what we can say, so we'll get CH3 CH2 14 COO minus K plus. So we'll get ethyl palmitate, potassium palmitate, potassium palmitate. Very simple reaction, because there is formation of this soap, that is soap formation. And when this reacted again with H plus H2SO4 amino acid or HCl, will get the same acid. And removal of minus KCl, that is K will be removed along with this H, so we'll get palmitic acid again. So here in the soap formation process, we get the soap is formed, that is metallic salts of soap will be formed on reaction of fatty acids along with what you can say the potassium hydroxide. Hydrolysis reaction will get potassium palmitate, like that, very simple reaction. And for more deeper knowledge, that is potassium salts are very, what we can say, soluble in water and very soft, rather than the calcium and barium salts, which are hard and insoluble in water. And unsaturated, the salts of unsaturated fatty acids are more, what we can say, are more water soluble and softer than the saturated fatty acids. Thank you.